Okay, this section is going to be how do you handle decimals with the different operations, add, subtract, multiply, and divide. So here's our study box to help us keep all the ideas in one place. I always think of this song like an old Western movie, and they're showing some ranch hands, taking the cattle cross country or something, and just kind of this slow lumbering clopping horse, and it like happy trails to you, kind of like a little song, because the rules for these go like this: line them up, add them up, and move them over. Makes me think of a Western. Sorry, that's how my brain works. Line them up, add them up, and move them over. It's what you do to the decimal. If in this case you got to make sure they line up. In this case you got to add them up, and you'll see in a minute. And in this case you move them over. So that's why I put the little musical notes. Heidi's brain thinks about a country song like that. So let's look at adding and subtracting. So line them up. It's basically the same thing as normal numbers. Like, when you had the number, let's say 526 plus 21. If you were going to add those, stack them up like this, you would stack it up this way, because you would make sure that your ones places matched up and then your tens places matched up. And that's what you do here so that you can add it. So you're adding together the same place value. Well, that rule didn't change just because we have decimals. That's exactly the same thought. You still want to make your ones places line up. And notice your ones place here is the number 6 and the ones place here is the number 1. So those are both ones places, just like these were ones places. You want to still make sure those line up. And they kind of teach us, well, just make sure the decimal lines up. And the reason the decimal has to line up is so that your place values are the same like they were when it was just regular numbers. So we need to make sure when we add this that the decimal lines up. And when you do it that way, you have ones places being added and tens places being added. Your same here with tenths and tenths are being added. So that's what happens when you line up that decimal, is it just keeps your place values lined up properly. And anywhere that you don't have a number, if you want one, you can just put a 0, because that means you don't have anything there. So we're just going to add normally. We're just going to say 4 plus 0, 1 plus 2, 6 plus 1, 3 plus 0, and 5 and nothing. So there's our answer to that one. Not too tough. Just line up the decimal. Same thing with the subtraction. We have 0.7654, and we're going to subtract 0.23, making sure that decimal lines up, or the ones place lines up, which however you want to think about it. So now if we want to subtract, again, if there's no number sitting here, you can put a 0 on there to give you a visual reference of what's really there. So 4 minus 0, and 5 minus 0, 6 minus 3, 7 minus 2, and 0 minus 0. And so that would be the final answer for that. And don't ever round off decimals unless they tell you to in the directions. If they tell you to round them, then round them. But if they haven't told you, then you're expected to write the whole thing there. Here's another one to similar exercise here. So if we're going to, I wanted to show you this one because I wanted you to see what to do. Think about if you had the number 50 minus, let's say, 24, like this. That usually what we do, we say, oh, 0 minus 4 doesn't work. So I come over here and I borrow. I take 1 away from here and I bring it over here and add it to whatever's there and call it 10. It's adding 10 there. And so now I have enough to subtract with. I have 10 minus 4 is 6. 4 minus 2 is 2. So 26 is the answer. So over here, the same kind of thing happens. Again, we don't have a number here, so we'll put a 0. 0 minus 8 doesn't work. We're going to come over here and borrow 1 from this, and that's like adding 10 to this. So that's 10. 10 minus 8 is 2. 1 minus 1 is 0. 3 minus 1 is 1. And there we go. 4 minus 0 is 4. So notice how the answer even lined up with the decimal. That's, the same thing happened up here. The answer lined up. Same thing happened up here. So, for adding and subtracting, it's line them up. They got to be lined up. Okay. Now for multiplication, it says you're going to add them up. So what you're going to do is you're going to multiply them as if they don't have any decimals. Like if it was 654 times 21, that's the kind of visual you want to give it. But when you get your answer, you're going to move the decimal from the right edge. You're going to move it this way. The total number of places you have in your problem. So there's 2 decimal places here and there's 1 here. So we're going to move the decimal in 3 places for the answer because there's a total of 3 places in these numbers. So I'm going to multiply normally. 1 times 4, 1 times 5, 1 times 6. And then, of course, since I'm moving over to this number to multiply with, I'll put a 0 here to hold that place value. 2 times 4 is 8. 2 times 5 is 10. Carry the 1. 2 times 6 is 12. Plus 1 is 13. Okay. And we'll add going straight down. That's 4, 13. Carry the 1, 7, 3, 1. Okay. So we did our multiplying. This is the number we came up with. And then looking back to the original numbers, there's 2 of them here, 1 of them here, and the place value of the decimals. So I have to move over from this edge, go over 3. Okay, so my final answer is 13.734. If you had, let's say you had 2.113 times 0.12. So you're going to just multiply everything. Don't worry about the decimal right now. 2 times everything on top. And then 1 times everything on top. And then add them up, going straight down. And then count up your place values that are in decimals. There's 3 of them here. There's 2 of them here. So these had a total of 5 decimal places. So starting right here, I want to move that over to 1, 2, 3, 4, 5 so that there's 5 numbers in the decimal place area. 1, 2, 3, 4, 5. Yep. So that's our answer. The last one, think of normal long division. Like if I said 2, how does it go into 156? I would be saying 2 fits into 15 7 times because 2 times 7 is 14. It's how many times 2 can fit into it without going over. So I'm going to put my 7 up here. 2 times 7 is 14. Put that down here. And then subtract it. Yeah. 2 goes into 15 7 times with 1 left over. That's what that's saying. So then you bring down the next number and then you do it again. Okay, 2 fits into 16. How many times does 2 fit into 16? 8 times, because 2 times 8 is 16, with no leftovers. So I put the 8 here. 8 times 2 is 16, and I'll subtract with no leftovers. So that's my answer. So we're going to use a similar concept over here. We're going to start with 0.003 into 0.0369. And what we're going to do is we have to, up here in the box it says move them over. And the reason we have to move it is because outside the box, outside of the division box, you do not want to have any decimals. It's okay if there's some inside, just not outside. So what we're going to do is we're going to move this over until there's no decimal left. And so it becomes just 3. And if whatever I do here, I have to do inside also. So if this moved 3 places to get rid of the decimal, then this also will move 3 places. So it moves over to between the 6 and the 9. So now that's the number we're going to work with to do our division. And so we say, okay, how many times does 3 fit into 3? Once. Then do that multiplying and subtract it. So there's nothing left over. Bring down the next number. How many times does 3 fit into 6? 2 times. 2 times 3 is 6. Subtract it. Nothing left over. Bring down the next number. 3 goes into 9 3 times. 3. Okay, nothing left over. Now, in the answer, the decimal will line up with where you have it, right here. So if the decimal was down here, right above it is where it's going to go in your answer as well. So for division, you move it over, and then wherever it moves to here, however many places on the outside, it has to move over the same number of places on the inside. And then wherever it lands, right above that is where it's going to be in your answer.